Hope you're enjoying your snow day. We're going to have a screencast on the laws of logarithms. First thing to remember, a logarithm is an exponent. So all these laws are based off exponent rules. So if you think back to exponent rules, we know that like x squared times x to the third is really x to the 2 plus 3 power. In other words, when you multiply with exponents, you really add. So when you multiply with logarithms, because a logarithm is really an exponent, then you really are just adding. You're taking the sum of the logarithms of the numbers. So a property is when you have this multiplication inside of here, so you can see there's a little multiplication inside of that logarithm there. So when you have multiplication in a log, the property says this, that you can split it up into two different logs, and you add them. So multiplication is really just addition in disguise. That's our first law of logarithms. Again, it's just based off exponent rules. Second rule, based off exponent rules, let's remember with exponents, if we have x to the 7th over x to the 4th, that's equal to the x to the 7 minus 4 power. When you divide with exponents, you really subtract. So that's true here. When you have the quotient, when you divide, it's really the difference of the logarithms of the numbers. So here we have division within a logarithm. So you really can separate it into two logs, and now that division turns into subtraction. That's the second law of logarithms. Third law, this was the hardest to see the connection, I think, between the two. But you remember this property. If you have x squared to the third power, a power of a power there, that'd be x to the 2 times 3, or x to the 6th power. So when you have a power of a logarithm, or a logarithm of a power, that's a power of a power, since the logarithm is an exponent. So you multiply. It is times there. So in this case, the c that starts up here ends up down here. So it's kind of like it can kind of move it out front, or if it starts out front, you can move it up top and make an exponent of that. So the c there, the exponent, can move down in front and multiply, or move back up there. So it's interchangeable. All these properties go both ways. So we're going to evaluate each expression using the laws of logarithms here. So in this case, the bases match, log 4, log 4. And so we're just going to work in reverse and say that's really log base 4 of 2 times 8. Or in other words, log base 4 of 16. Which I hope you can see that go, that's just 2. And it kind of made it easier to push it together, because log base 4 of 2 is not an easy one to do in our heads. Log base 4 of 8, not easy to do in our heads. But if you put it together, 2 times 8, 16. Oh, yeah, log base 4 of 16 is 2. And so here now we have an exponent. So you can see the property that's in play there. We can then move that down. So this is going to be equal to 49 times log base 3 of 9. And so we have 49 times, I hope you see log base 3 of 9 and go, oh, that's just 2. And so the answer is just 98 there. This one may not look like an exponent in disguise, but it is an exponent. So this would be log base 2 of 8 to the what fractional power? If you think about the fractional power there, this is second root first power there. So this is 1/2 power. Well, now that we see that 1/2 power is really just a square root in disguise, we can move that down. And so we can say this is 1/2 times log base 2 of 8. And log base 2 of 8 is 3, so 1/2 times 1/2 times 3 is going to be 3/2. So now I'm going to use the laws of logarithms to expand the expression. There are two requirements. If you are going to expand an expression, these two things must be true. There should be no multiplication inside of the logarithms, and there should be no exponents in the logs. So right now this expression is not fully expanded because there is multiplication inside of that log. So I'm going to break it apart. Log base 2 of 7 plus log base 2 of x. And so then we're done. We're not trying to simplify this at all. We're just trying to expand the expression. So we want to get an expression that does not have any multiplication inside of logarithms or any exponents inside the log. So you can see that now we do have an exponent there because square root, we just learned, is an exponent in disguise. So you would write log of 3 to the 1/2 power. And then see that is really an exponent there, so we can move that down. So this is going to be 1/2 times log base 10 of 3. And that's okay because there's no exponents or multiplication inside of the logarithms. Now this is a pretty tough one here. We're going to attempt this one. I see this division first, so I'm going to do that one first. I think it makes the most sense. Natural log of x times y minus natural log of z squared. So then I've got a couple issues here. I have a times sign there. I have an exponent there. That needs to move out. This needs to break it apart. So this is going to be natural log of x. Sorry, that's really sloppy. Plus natural log of y minus 2 times natural log of z. And now we're going to go the opposite way. So this is called combining or compressing logarithms. The requirement is we need to make it into one logarithm. So it may start out as 2 logarithms, but it's got to end up as 1 logarithm. I can't push these together because I have a coefficient. The law of logarithms says you have to have a log of something plus a log of something in order to push it together. So I've got to move this up first before I do anything. I can't push that together until I do that. So log base 3 of 4 plus log base 3 of 2 to the 2nd power. So I moved that 2 up there and made it an exponent. Now I'm going to push those together as 1 logarithm. So this is going to be log base 3 of 4 times 2 squared. That's 2 squared there. And I don't care if you multiply that. 4 times 4 is 16. You're welcome to put that if you need to there. That's a 2 up there. Or you just put 4 times 2 squared inside of there. I'm okay with that. Notice it's 1 logarithm. That's all I care about. You don't have to simplify this. Don't think simplification. You're just writing as 1 logarithm. You can't push these together right now because I've got coefficients there. I've got to move those up before I can push the logarithms together. So I'll have log of y to the 1/2 minus log of x squared minus 1 squared. Now I'm going to push those two things together because minus subtraction is really division in disguise. So this is going to be 1 logarithm, log of big fraction bar. Up top we have y to the 1/2. If you want to write that as square root of y, I'm fine with that. In the denominator it'd be x squared minus 1 squared. That's 1 logarithm. It's not simplified, and that's okay. It's compressed. That's what we want, 1 logarithm. Last principle of the day, last part of your lesson today, is a change of base formula. We used to use this a lot with calculators because we couldn't change the base on the old calculators before TI and Spire came along. And so it was a base 10 or base E, and now, so we had a problem like this. We couldn't type this in our calculator, but you can now. If you follow this formula, then what you do is you take the log of, say, 5 divided by log of 3 is equal to log base 3 of 5. So you can change the base. In this case, I changed the base to 10. I could have changed the base to E. So I could have said natural log of 5 over natural log of 3. That's going to be equivalent to log base 3 of 5. And these you can both type into the old calculators, which was handy. This is the purpose, I think, of this change of base formula. Occasionally you might use it in calculus or something, but many times it was just because we couldn't type log 3 of 5 in our calculators. Now we can. And so we can literally change the base to anything. I changed it to base 7. You could change the base to anything. if you use the change of base formula. That is your lesson. It's about a 10-minute lesson. Hope you enjoy the rest of your snow day.